We're on the last lesson of chapter 6, which is spheres. We're going to find the volume of a sphere, then we're going to find the surface area of a sphere, and then do a real-world application. So unlike a circle, which is a set of points on a plane that are a given distance from the center, or in 2 dimensions you could say, a sphere is a set of points in 3 dimensions that are fixed distance from a given point. So this line could go in any which direction, up, down, left, and right, and all the points on the sphere, or this ball, I guess you could call it, are going to be 8 meters from that center point. We're going to find both volume and surface area of the sphere. You notice that for both formulas you have pi times the radius, which is cubed here and then squared here. For volume, that would make sense that it's cubed because it's in 3 dimensions. Surface area is only in 2 dimensions, so that's why it's radius squared. So that's your starting point for both formulas, except you cube it here and square it here. Now the major difference is you multiply times 4/3 for volume and 4 for surface area. You're just going to memorize these formulas. So if we want to try this out, we would do pi times radius cubed. So 8 cubed would be 8 times 8 times 8, 512 times 3.14. So 1607.68 would be the parentheses here. Then times 4 and divided by 3 would be 2143.6 if we're going to round to the nearest tenth. And that would be meters here, meters cubed. If we're going to do the surface area, we would square that 8, so 64 times 3.14, 200.96, and then multiply that times 4, 803.84. That would be meters squared in that case, because surface area is a square measurement. Now that we know both formulas, let's give it a shot. It says find the volume of a sphere with the radius of 9 feet, both in terms of pi and to the nearest tenth. Use 3.14 for pi. So if I copy this formula here, so we plug in that 9 here. So we have 4/3 times pi times 9 to the third. If we do 9 to the third, 9 times 9 times 9, 729. So we have 4/3 times 729 times pi. So it says solve in terms both of pi and to the nearest tenth. So we can do 4/3 times 729, and that's what we would multiply times pi. So 4 times 729 divided by 3, so 972 times pi. Then if we actually solve that, we do times 3.14, that would be 3052.1 if we're rounding to the nearest tenth. So that would be feet cubed. And as would this one be as well. So if this is in terms of pi, 972 times pi feet cubed, or 3052.1 feet cubed without the pi. Both of these answers are needed. Here it says to find the surface area both in terms of pi and to the nearest tenth. So we plug in this formula here, 4 times pi times radius squared. We're going to plug in the 4 for the radius here. So 4 squared would be 16. So we'd have 4 times 16 pi. Multiply the 4 times the 16. And that would give us 64. So in terms of pi, it's 64 times pi millimeters squared. Remember, surface area is measured in squares, not cubes. Then if we solve that, 64 times 3.14, 200.96. If we're rounding in the nearest tenth, this would actually round to 201.0, or just 201. So 201 millimeters squared. So remember, both of these answers are needed, both in terms of pi and without pi. So here we need to do a little bit of a comparison. It says compare the volume and surface area of a sphere with a radius of 42 centimeters with that of a rectangular prism measuring 36 by 88 by 63 centimeters. First, let's focus on the volume. I have the formula over here, so I have 4/3 times pi times the radius cubed. Plug in the 42 for the radius cubed. So we do 42 cubed, 42 times 42 times 42, 74,088. So 4/3 times 74,088 pi. So 7488 times pi is 3.14, would be 232,636.32. We can multiply that times 4 and divide it by 3 then. Times 4 divided by 3, which gives us 310,181.8. And that would be centimeters cubed. So we're going to call this volume of the sphere. So let's compare that to the volume of the prism. We know the volume of the prism is the base times the height. So 88 times 36, that's the area of the base times the height of 63, so 199,584. Volume of the prism, 199,584 centimeters cubed as well. So we see the sphere actually has more volume. Many people don't expect that because of the 42 here. They see that's the smaller number. But remember, a radius is actually only half all the way across. So the diameter is actually 86, if that helps. Now let's look at surface area. I'm going to get this formula out of here and keep these over here. The formula for surface area for a sphere is 4 times pi times radius squared. So 42 squared, 1764. So 4 times 1764 times pi. 1764 times 3.14 for pi is 5,538.96 times 4 would be 22,155.9. So SA for surface area of the sphere would be 22,155.9. That'd be centimeters squared. We have not learned surface area of prisms yet, but if you think about it enough, you can figure out what to do. We need to find the area of all 6 sides of this prism. Well, I know that this bottom side and this top side are the same, so I could find this and multiply times 2. I know that this side and this side are the same, so I can multiply this times 2. And I know the front and the back are the same, so I can do the same thing. So let's do the bottom and the top. 36 times 88. 36 times 88. So that's the area of the bottom base. So times 2, because there's 2 of them, is 6,336. Plus, now let's find the sides here. So 36 times 63 times 2, because there's 2 of them, 4,536. Now let's add the front and the back. So 63 times 88 times 2, 11,088. So if we add all 3 of those together, plus 4,536 plus 6,336, we have 21,960. So surface area of prism, 21,960. That would be centimeters squared. So we see that the surface areas are much closer together than the volumes, yet in both cases the sphere has greater numbers for both volume and surface area.